All right, so today we are going to start our next unit, which is about radicals. Okay, now the first thing that we have here is our perfect square chart. I've already gone ahead and filled mine in, but filling this in is pretty easy. Basically, all that we're doing is when you look at this chart, going from the left side to the right side, you're taking the number on the left and you're squaring it. Okay, and squaring something means you multiply it by itself. So when I'm going from this side to this side, you take this number and you square it. Okay, so 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16, and so on and so forth. Okay, so you just take all these numbers here and you multiply them by themselves, and that's how you get the number over here. Okay, so we did a lot with exponents last unit. What we're more working on this unit is we're working on how do you go the other direction. So if I'm starting here and I want to go in this direction, okay, and that is something called a square root. Okay, or a radical. A square root's just like a particular type of radical, just like how a schnauzer is a particular type of dog, right? So we're talking radicals is like kind of like saying dogs, and square roots is kind of like saying a schnauzer. Okay, so we're talking about a particular one, a square root. Okay, so when you take the numbers on this side and you take their square roots, that's how you get back over here. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay, so what a square root asks you is it asks you what times itself equals this number. So when I ask you what's the square root of 16, I want to know what number times itself equals 16. Okay, and the answer to that question is 4. All right. When I ask you for the square root of, say, 49, I want to know what number times itself equals 49. And the answer to that is 7. Okay, so this table is going to be really helpful for you as you're answering some of these questions throughout this unit. All right, so you want to make sure that you have this table handy that you can use as a reference. All right, so let's talk about some of the things that we are going to do with these radicals. So the first thing we're going to look at is converting radicals and estimating what they are as like a decimal, okay? So converting radicals, what I mean by that is that you can write square roots in two different ways. You can write square roots kind of like this guy with a square root in it, or you can write them like this with a special kind of exponent, a fraction exponent. Okay, so that's the piece that we're going to look at first. So let's start with when we have them in radical form. Okay, so first of all, just a little bit of vocab. So there's my radical symbol. All right, you have a number that goes on the inside, and that inside number we call the radicand. Okay, so the inside number in a radical we call the radicand. All right, and then sometimes there's going to be a little number written up here. I'm going to put an N there, and it's sort of a number that shows up kind of like inside the check marky part. Okay, so it's not a number in front, it's a little bit different. So if you kind of take a look at like this guy, see where that 3 is, or where the 5 is on this one, right? That's what this index number is. Okay, so that little number up here, that's called an index. And what that tells you is like how when we looked at a square root, we said a square root asks you what times itself equals this. Well, your index number tells you how many times you want the number multiplied together. So like if you had a little 3 for your index number, that would be asking you what number times itself 3 times equals this. And if it was a little 4 as your index number, it would say what number times itself 4 times equals this. Okay, so that's what the index number does. All right. And then sometimes on these, you're going to have some sort of a power up top. Use P for power. Okay. So this guy right here, that would be your power or your exponent. Okay. So we spent a lot of time working with exponents, and now I'm suddenly calling them powers. Why on earth did I suddenly stop calling them exponents and start calling them powers? Well, for two reasons. One, those are synonyms, and you should be familiar with both of them, that they're both good titles that you can use for that. All right, but also it's going to kind of help us with the next thing that we need to do if we can think of it as a power. Okay, because the first thing that we're going to need to do, converting, what I want you to be able to do is take something that's written in this form and rewrite it so that it looks like one of these. So it looks like some sort of a number with a fraction exponent on it. Okay? So when we go to convert these, you can go back and forth between the two different forms. All right? And here's how we're going to know to do this. So the radicand, the number on the inside, that's going to be like your normal sized number. Okay? And then we're going to have an exponent on that that's going to be a little fraction. So that's like my fraction line in my exponent. All right? And the way that you convert this is the exponent from here is going to go on top, and your index number from here is going to go on the bottom. Okay, so that's what your fraction is going to be. Now, how do we remember this? Okay, well, I remember it by kind of changing the names a little bit. So just like how I said we would call this a power instead of an exponent, I kind of think of the index as the root. Okay, so like what root it is. All right, and that helps me because then I can kind of look at this and I think, okay, well, this is the power and this is the root. And you're like, Miss King, how is this helpful? Well, the way that I can remember what order they go in is I just think of a flower, right? Because in a flower, the flower part is up top and the roots go on the bottom, right? Those are the things that grow below the ground. So the flower is on top of the roots, just like how here the power goes on top of the roots. Okay, so it's always power over root. All right, so that's going to be the first thing that we're going to do is we're going to work on converting these a little bit. Okay, so let's skip these two for right now, and I want to jump down and do some of these switching form ones. Okay, so I'm going to ask you to convert between the two different forms. So like these two problems, they're already in this form. We're going to switch them to radical form. Okay, these ones, these are already in radical form. We're going to switch them to exponent form. So let's take a second and just write that up here. So this guy up here, this one would be called radical form. Okay, and this one over here is called exponent form. Okay, great. All right, so if I wanted to convert this from exponent form to radical form, it's pretty easy. I'm going to draw my little radical. That x, that normal sized x number, that goes on the inside. And then I just have to remember that it's power over root. So 1 is the power and 2 is the root. So I'm going to put a 1 here for my power, and I'm going to put a 2 here for my root. Okay, let's do this one. So same deal, we're going to make our square root. We're going to put this 5 on the inside, and then it's power over root. So my power is 2, and my root is 3. Okay, you want to make sure that when you're writing that root number, it should look like it's kind of inside that check mark. You don't want it to look like a normal size number in the front because that means something different. All right, so now let's go the other direction. So these next two, we're starting in radical form and we want to write it in exponent form. Okay, so in this one, the 5 is going to be my normal size number. And then remember, this is your power and that one's your root. So when I write my fraction, it's power over root, just like flowers grow over their roots. So it's going to be 4 over 3. Okay, and then this one, I'm going to have a regular sized x, and then power over root. So it'll be 3 over 5. Okay, and that's how you convert back and forth. So it's not super hard. You just have to kind of remember that pattern and remember this power over root thing. All right, so we've looked at our first thing, switching between these two forms, but you might be thinking to yourself, but Miss King, like, how do I actually do stuff with these radicals? Like, what do I do with them? What are they? What's the point? Okay, and that's what we're going to talk about in these next two sections. Okay, so first of all, these ones say simplify, but what I want you to notice about these is that they have a square root and a squared. Okay, so squaring and square rooting are inverse operations. Okay, that's the whole point of them. So it's kind of like how if I have like x and I say plus 3 and then minus 3, right? Well, plus 3 and minus 3, those are inverse operations, right? So they kind of cancel each other out and you're left with just x, right? Or if I say something like x times 2 and then divided by 2, right? Well, multiplying and dividing are inverse operations, so they cancel each other out and you're left with just the x. In the same way, if you have an x and you take a square root of it and then you square it, just like how adding and subtracting are inverses and multiplying and dividing are inverses, squaring and square rooting are inverses. So this one, it's a little bit harder to draw the line through, but those guys cancel each other out and you're left with just the x. Okay, so when I look at these two expressions here and it says the square root of 10 squared, I look at that and I say, oh, those are inverses. So this squaring and that square rooting cancel each other out and I'm left with just 10. Okay, same thing over here. This one looks like it's going to be really hard. That's a big number, right? But squaring and square rooting cancel each other out and I'm left with just that 1823. You don't have to do any math to figure it out. I just want to know that you realize that squaring and square rooting are opposites. All right, great. Now the next thing that we're going to do is we're going to talk about estimating square roots. So basically what I want you to be able to do is I want you to be able to look at these and give me an idea of where they go on a number line without using a calculator. Okay, so without using a calculator, we're going to figure out where these numbers go. All right, and this is where we're going to go back to our table. Okay, so that's where this table is going to be really important. Okay, because remember we said that if you have a number over here and you take the square root of it, that's what you get over here. Okay, so when I look at these, if I had something where it said, say, the square root of 9, I know that would go exactly at 3 on the number line. Okay, if I had the square root of 64, that would go at exactly 8 on the number line. Okay, because that's what a square root is. So with this one, they asked me for a square root of 10. Well, that's not anywhere on my table here. But what I can do is I can say, all right, well, I know that the square root of 9, right, would get me 3. And the square root of 16 would get me to 4, right? The square root of 10, that would be somewhere in between those, right? So when I look at this, I can say, okay, well, the square root of 10 then is going to have to be somewhere between 3 and 4. And since 10 is a little closer to 9 than it is to 16, it's going to be a little closer to 3 than it is to 4. So on my number line, I'm going to come over here and I'm going to put my point between 3 and 4, but a little bit closer to 3. Right? And that's where the square root of 10 goes. All right, next one, square root of 2. All right, so square root of 2, right? I'm looking over here. I know the square root of 1 would be 1, and I know the square root of 4 would be 2. So the square root of 2, that would go somewhere between those two, right? So if the square root of 1 is 1 and the square root of 4 is 2, and this is somewhere between, then it's going to be between 1 and 2. And since that's a little bit closer to 1 than it is to 4, it's going to be a little bit closer to 1 on your number line. So I'm going to go between 1 and 2, a little bit closer to 1, and that's where the square root of 2 goes. All right, square root of 110. So I'm looking over here. Oh, here's the square root of 100. So the square root of 100 is 10, and the square root of 121 is 11. So 110 is going to be between those two numbers. It's about halfway between. So I'm going to put this on my number line between 10 and 11, and about halfway between those two numbers. So between 10 and 11, about halfway, that's where the square root of 110 goes. Okay, lastly, the square root of 200. So square root of 200, I'm looking over here. Well, I got a square root of 196 and a square root of 225. So 200 would be between those, right? The square root of 196 is 14. Square root of 225 is 15, right? So the square root of 200 would be between those. It's closer to 196 than 225. So I'm going to put my point between 14 and 15, but closer to 14. So between 14 and 15, but closer to 14. That's where the square root of 200 goes. Okay, so if I asked you to give me an estimate of what the square root of 20 is, you'd say it's a little bit more than 14. I'm sorry, the square root of 200. Okay, if I wanted you to tell me square root of 110, how much is that? Well, it's about 10 and a half, right? It's a little bit more than 10, less than 11, somewhere between 10 and 11. Okay, if I want to know what the square root of 10 is, well, it's a little bit more than 3. Okay, so that's the pieces that we're looking for here. So for today, what am I looking for from you? I want you to be able to give me an estimate of what a square root is without using your calculator. All right, I want you to understand that squaring and square rooting cancel each other out. They're inverse operations. Okay, and I want you to be able to use this property to switch back and forth between the two forms.